Thank you to Red Hat for the opportunity. Hi, I'm Eyal Sivan. I'm a Senior Director with CIBC's Enterprise Architecture team. Been with CIBC for 15 years, and I'm here to talk to you about open banking, specifically building the optimal architecture for open banking. Should be fun. I've got a bunch of techies in the room. Last time I gave this talk, it was to more of a business crowd from the open banking side, and I was worried about keeping it light, but this should be fun because I'm going to go in a little deeper with you guys and talk about the specifics of what that architecture is going to look like. So let's jump right in. Banks are evolving. There's no getting around this. They're evolving all over the world. And they're evolving into technology companies. We see this happening across the board. Here's the eye chart. You're not intended to read every last little label on there. It's really intended to give you the sense that everything is changing, that in every single space that a bank operates in, we're seeing technology radically impact how they do business. It doesn't matter if it's retail, wholesale, capital, insurance. Across the board, banks are trying to adjust to the massive impact that technology is having on them. Now, as they try and transform into technology companies, that means something very particular. That means innovation. It means they have to learn how to innovate better. And there are three major pressures that are forcing them to learn how to do this. One is rising consumer expectations, right? Everybody knows what I'm talking about. They just need to reach into their pocket and get their cell phone, right? You now expect that kind of experience from everyone you do business with, not just your taxi companies and the folks renting your rooms, but your banks as well. The second major pressure is competition from fintechs. We talked about this at length. The GAFAs are coming for us, the tech fins, the fintechs, non-bank entities who offer financial services are creating enormous market pressure. And the third one is the regulatory environment. All over the world, you see the rise of open banking legislation and other related legislation that drives that drives banks to rethink how they do banking. They're forced to by government regulation. So we have to learn to innovate. We have to learn to behave like technology companies. The thing is, that requires a whole new set of skills that we have to go out and learn that we historically have not had to do. Those include things like Agile, DevOps, Cloud, and of course, APIs, right? Maybe you've heard of them, APIs? No? Show of hands, right? The rise of the API. APIs are nothing new. They've been around since the 70s. They're the term that just refers to how you get software to talk to each other. So there's really nothing new in the particular phrase API, but they're enjoying somewhat of a renaissance on the back of REST and JSON and other new technologies that make them very easy to create and very easy to use. Now, as everyone in this room knows, APIs did not come along with open banking. We've all been working on our API strategies now for several years. APIs are fundamentally a way to take your business and break it down into reusable chunks, and then share those chunks. This is an exercise that we've been going through for several years internally. This isn't something we've worried about the external landscape and how to create public APIs. We focused on strategies that allow us to break our businesses down into reusable chunks internally, so that we can improve internal sharing. There was that famous Bezos mandate that says when you build stuff in-house, you build it as if you were building it for a third party, as if it was an external product. So that idea of I'm going to break my business down into these reusable APIs is an idea that we've been working on for a couple of years now. What's new is this idea of taking those APIs and making them public, making them accessible in a way that anybody can go and start using them. Once you move into that world of publicly accessible APIs that anybody can sign up and use, you are now in the realm of open banking. You're now in the realm of sight unseen. Folks are going to come to you and through some developer experience that you offer them, integrate with your bank. That is a new idea and has really turned into what is intended by the term open banking. Now, ostensibly the goal of every bank going down this road is to create a collection of open APIs that you then build a bunch of partners, developers, a network of folks who are using it, and create this robust open banking ecosystem around your marketplace. So everybody's got roughly the same goal. Take my business, break it into reusable chunks, Make those chunks APIs, make them easy to use, create a great developer experience, publicly accessible, put them out there and get developers to start using them. Open banking. The thing is, open banking means different things to different people, depending on who you ask. This is the kind of slide that you're going to see a lot if you go to open banking events. Eric had a slide like this in his presentation that shows you the global landscape. Now what you'll see here is a chart from A.T. Kearney where they try and plot the activities within each of the countries across two axes, regulatory and market-driven. The way they classify it is regulatory is a push, the idea being that you are regulated into adopting these technologies, and market-driven is a pull, where you're essentially pulled into this innovation by market forces, by competition. As you'll see, a lot of activity all over the world. The sort of centers of activity are, weirdly, to see them together, the US and China, who are largely market-driven. They don't have any major regulatory framework and are trying to go down this road in a largely market-driven way. And then you've got the CMA9 in the UK and the PSD2 efforts happening in Europe, which are really the centers of the regulatory activity, where the governments are aggressively passing laws that require, mandate banks and non-bank entities to adopt certain standards that allow them to open up their data. This is really a presentation about technology. Now what's interesting about the technology side is that whether you go market-driven or whether you go regulatory-driven, in many ways you end up in the same place. And you have fundamentally the same goals. And those goals are competition, innovation, and transparency. That goes for all of open banking. Even if you're market-driven, you're trying to create a more competitive landscape that allows for non-bank players to be able to participate in the banking ecosystem, driving down prices for consumers, creating efficiencies, and so on. You're trying to drive innovation by supporting new technologies and creating the capability for new kinds of user experiences to be easily created on top of these banking systems. And you're trying to drive transparency, particularly price transparency and transaction flow transparency, which is intended to reduce fraud, reduce friction, and enable more flow overall. So let's take a look at how these two different approaches influence the solution architecture. Because like I said, that's what this is really about. If you strip away the arguments about regulatory versus non-regulatory, you end up in a lot of this, with a lot of the same conclusions. But where you see differences is in the influence these two approaches have on the solution architecture. So, what do we see out there? We see that when you take a regulatory approach, you end up focusing on the APIs. You end up focusing on the developer experience. Make sure that your bank has these 4 APIs exposed, that you provide these facilities, and make sure that the developer experience is accessible and usable and that there's consent flows built in. And at first blush, you look at all these specifications and it looks pretty good, right? You've solved all of these wonderful API problems. The issue is that there's nothing in the regulation from any region that requires you to do anything about your back end. What that means is that in the regions that are heavily regulated, you're taking banks that are not ready to move towards a wholesale refresh of their technology stack and telling them, focus on the top. Forced march. By such and such date, you have to have these APIs published. You have to have a developer portal. You have to have support for the developer portal, and so on. Now, like us, those banks are constrained when it comes to IT resources. So they're going to take what they have, which is not enough to service the whole stack constantly, and put it on the top of the stack, on the developer experience, on the APIs. So they're going to get very, very good at that, but they're going to miss everything that's happening under the surface. Now, in market-driven environments, like ours so far, we don't have any regulation in place, we've taken those scarce IT resources and focused on something else. We've focused on delivering software faster. And we've done so by focusing on all of those other things that don't have anything to do with necessarily creating great APIs. They have to do with improving how we code, package, deploy, test, and run software, right? Things like agility, consumer-driven contracts, precise scaling and enhancement, distributed data with events, unstructured big data lakes, automated DevOps deployment, public cloud support, all of which can be wrapped in a big bow that you could roughly call continuous improvement, or CI/CD if you're into the acronyms. So in the market-driven world, you see this focus on something completely different than improving developer experience and APIs. You see this focus on trying to behave more like technology companies in the sense of a pipeline, in the sense of reducing batch sizes and increasing velocity. The thing is, to do open banking properly, you need both. If you are just going to focus on the API layer and creating a solid developer experience, but not touch your back end, you're going to find yourself very constrained when those developers start asking for changes. On the other hand, if you only focus on a delivery pipeline and rolling out batch sizes, but you don't touch your API management, well, then you're just going to have a lot of microservices that have ill-defined APIs that nobody really understands or can use. Right? So how do you sort of bring those two worlds together? API gateways. Right? If we've all been working on this problem for a few years, this is a term that we have definitely run into. The thing is, there's API gateways and there's API gateways. They're not all the same. You've got big, fat, honking ones, and then you've got little, tiny ingress, egress, small footprint ones, both of which call themselves API gateways. Well, how can that be? So to understand this, you have to look at what vendors have meant historically when they try to package API gateway solutions. Historically, they have meant the picture on the left. Okay. Right. On my right? On my right. So on your left, on my right. You'd think I'd get that by now. So it's what I like to call the magical black box approach, and Eric alluded to this. What that essentially means is I'm going to wheel this thing into your shop. It's going to control all the traffic between all your systems and just take care of all your problems for you. Eric talked about this. This approach has gone by different names. I've been in this industry long enough that I've seen it come and go by different names. Today they call it API gateways. Not so long ago they called them SOA, Enterprise Service Buses. Before that, EAI. Before that, ERP. Right? And you can keep going back. This idea of, oh, just take your spaghetti and put it in my giant spaghetti bowl and it won't be spaghetti anymore, is an idea that IT professionals have been hearing for decades. And at least in my experience, it's not something that works. You end up spending a lot of money on a proprietary technology, a ton more on labor because you need these specialized resources, and you often end up dumping the thing because you didn't gain the benefit. You didn't recoup the investment from that spaghetti bowl that you thought was going to solve all your problems. In many ways, it was those failures that led us to the architecture on the right, which is microservices, right? Specifically as regards gateways, the difference is that in the magic black box approach, you're taking a centralized gateway pattern. And what that means is you're going to have one traffic cop. All the traffic is going to flow in and out of this traffic cop, and he's going to handle all of your cross-cutting concerns for you, your security, your logging, your metrics. The thing is, passing all of the traffic, especially when you start to scale out your microservices, you create a single point of failure, you create a scaling point that is very, very difficult to scale, and you don't really get to that part where you can start to increase your velocity dramatically because you're stuck with this monolithic gateway that you have to incorporate into your development cycle. So the more modern approach is a distributed gateway approach. And what that means is that rather than having a single traffic cop, you create a very lightweight gateway and you deploy it inside each of your individual microservices. This isn't something that CIBC invented. This is a pattern that is sometimes called distributed gateway and is very close to a pattern known as the microservice chassis. The most popular implementation of this by far is Spring Boot. Right? I've got my own sort of issues with Spring Boot, but as far as a reference technology that implements a distributed gateway pattern, that's exactly what it's doing. There isn't a central gateway. You're embedding a tiny gateway into each individual microservice, thereby spreading the load and really taking to heart that famous Martin Fowler quote, smart endpoints, dumb pipes. You don't have any smart pipes. You don't have any logic concentrated into some proprietary mediator. You've pushed all the smarts down to each individual service, allowing you to deploy them and scale them independently. So to understand why that's a benefit, you have to understand a little more about microservices. Now, I know most of you folks are probably familiar with this distinction, but bear with me. The difference between APIs and microservices. This is something we all understand pretty well, but you'd be surprised when you go to those regulatory-driven regions and talk to them about open banking, where they have been so laser-focused on APIs, and you start to talk to them about this distinction, they really don't get it, right? They think APIs and microservices are the same thing. But we know better. We know that APIs are just a contract. APIs have no code in them. They are an agreement. They say, if you send me this input data, this is the output data you're going to get back. It doesn't matter what format. You're talking about SOAP, REST, REST JSON, GraphQL, gRPC. In every case, the API is just a contract that says, if you send me this input, I'm going to send you this output. You can implement that API any way you want. You could implement it, in other words, write the code that makes it work, on a 40-year-old mainframe, or using hot new microservices. But it's the difference between those two that is the secret sauce, right, is what gets you that delivery speed. The difference is best illustrated by example. Let's say you have a 40-year-old mainframe. That mainframe does 10 discrete functions, and you want to move to APIs. You've got a compliance exercise. You're trying to get to open banking. So you use some amazing API gateway tech with some adapters that hook into IMS or something like that, and you create 10 APIs on top of your mainframe. And I'm going to grant you that they're the most beautiful APIs you ever saw. REST, JSON, developer-friendly, easy to understand. You put them up in a beautiful developer marketplace where developers can come and try them out and play with them. And everything's great until those developers start to ask for things. Until that 10th function on that 40-year-old mainframe gets really popular and starts to have to handle 1,000 more hits a day than it was handling prior. Well, now you have a problem. Developers love that 10th API. They start communicating with you through the marketplace saying, give me a couple more fields, give me additional functionality. And you say back to them, I'll see you in 6 months, if you're lucky, because that's how long it's going to take you to change the mainframe. Take the microservices approach. Each one of those APIs is implemented on its own microservice. I can change the 10th one without touching the other 9. I can scale it. I can add additional functionality. I can have it be running in a completely different environment. I can have one API running in Azure, another one running in Amazon, and the third one running on-prem. That's the power of microservices. And that's something you only get with microservices. Again, I stress, no matter what you do with the APIs, you're not going to get that benefit. It's all about what's under the surface. And that's where microservices come in. And generally speaking, to answer an earlier question, you're implementing a microservice per API. The granularity of the API is something you determine in your design exercise. The design practices out there generally say, does the thing change a lot? If it changes a lot, that's probably a good boundary for an API and associated microservice. If that thing that changes all the time is very fine-grained, well, that's good enough, right? The fact that it changes a lot. If it's very coarse-grained, that's fine too. So you're trying to look for those boundaries of change, because fundamentally, the reason you're adopting microservices is to be able to handle high velocity, to be able to handle rapid change, thereby giving your bank the ability to evolve rapidly. And that famous word, innovate, right? So that's what gets you to this high-speed release cycle. But I don't want to oversimplify it, because microservices themselves are on a journey, right? This is not a fixed target we're talking about. This is something that only in the last year or so, I'd say we've gotten to a point where we're not having the argument anymore about whether microservices are good. Folks get it. We're trying to move to this world of high speed, and the only way you can get high speed is by having these wonderful containers running on Docker that fit in your CAS, in your Kubernetes or OpenShift environment. So we're not having that argument anymore. The thing is, you've still got this moving target. So even organizations that have adopted microservices, in a lot of cases, they're still running a monolithic API gateway. So they've deployed a bunch of microservices, but they've still got that traffic cop handling all of the traffic between the microservices. So you hit that same single point of failure, you hit that same scaling issue. However, most of the API gateway vendors are still firmly in this monolithic space, right? Make no mistake. Use one step forward in the evolution and you get to true microservices with a microservice gateway. This is what I was alluding to earlier, the distributed gateway pattern, where you've embedded a tiny gateway into each individual service. The tech companies that started to go down the microservice and API road didn't even bother with the first one. They went straight at the second one, and they did that with libraries. So you'll hear names like Hystrix and Finagle and other library code bases that essentially created this MSA chassis pattern for various tech companies. Spring Boot really leaned into this approach, and as did a bunch of others. And now you have a number of true microservice solutions where the gateways are embedded into each individual microservice, and each individual microservice handles its own cross-cutting concerns, the logging, metrics, security, etc. Inside each individual service, immutable, you can pick them up, you can move them from one cloud provider to another. Very powerful stuff. Thing is, even those tech companies started to realize, wow, these libraries are a pain in the butt. I have different versions, I have to support different languages, I have to have developer discipline around using the same libraries in different places. For companies that were monolines, like a Netflix or an Uber, not that big of a problem. They don't have that many different products to sell. They don't really have a federated development environment, so trying to force developers to use particular libraries, not that difficult. But once you get into organizations like ours, that have a federated structure, that have many different lines of business, that have often competing interests, this approach of trying to maintain a common set of libraries across the enterprise becomes very unwieldy. Google was the first to sort of run into this problem along with a few others. So they matured their microservice architecture to move towards something new, something they call the service mesh. Now, service mesh architecture is so new that we're still wiping the muck off the newborn baby. It's very new. It is, I believe, keep me honest here, August 1st of last year was when Red Hat and Google ratified the 1.0 spec for Istio, which is currently probably in the minds of technologists out there, the leading service mesh. Now there are other upstarts, Conduit, Linkerd, OpenContrail. That's only to show that startups who are trying to get into this space, they go right at service mesh. They don't even bother with the first two. Now, what's different about a service mesh versus straight microservices? You're not embedding the cross-cutting concerns, the distributed gateway, inside the microservice anymore. Instead, you're creating a sidecar, a tiny proxy that sits alongside each microservice as a dedicated contact point. And you essentially manage this network of sidecars as a contact surface for all of your microservices to speak to each other. So you take away all the liability of dealing with libraries and code management and still get the distribution that you wanted in terms of distributing load, smart endpoints, smart pipes, and maintaining your delivery velocity by being microservices soup to nuts. Note that while this is probably the most advanced commercial approach you can take today within the enterprise, and vendors like Red Hat are still filling in the gaps for us and working with us to get the service mesh to that point that it's enterprise ready, make no mistake, it's a moving target. This stuff is still going. Service mesh is not the end of this story. Over the horizon, we already see serverless architectures, such as Lambda from AWS, that say, you don't even need a mesh. Give us your source code, we'll deploy it into the public cloud, and auto spin up a sidecar for you. You won't even know what happened, right? We're not there yet. Right? The reason that I decorated the font in that sort of light color was to indicate not ready for prime time use in the enterprise. If you've got some labs, by all means, throw them at Lambda. Great to learn. But it's really up there to illustrate that we're trying to hit a moving target here, which means our biggest constraint is learning about this stuff, understanding it in the larger context of where it is we're going. Those who understand this microservices architecture and the state of the industry relative to this architecture are going to be the leaders, and their lead is going to continue to be extended as the volatility increases. The volatility is not going away. The volatility you see now in the gateway market, if anything, it's getting worse in light of this evolution. So what folks thought was going to happen was we're going to move from gateways to this sort of microservice, and the dust was going to settle a bit on microservices, and everybody was going to go off and do something that looks like Spring Boot. Don't bet on it. Stuff is moving, and it's moving fast. And for us to do our jobs, we have to understand where it came from, where it is today, and where it's going. So where is it going? What does this look like? Now I'm going to point out here that I did use the word optimal intentionally. The original slide was called the right architecture, but I backed off of that in light of the previous slide. I don't want to give you the impression that this is something you can call an end state and point to and say, you're done. Oh yeah, this is what Eyal said was the end state for this stuff. This is the right architecture. I'm adopting this architecture. It's our blueprint now. In 3 years, we'll be there. Right? That's not the goal. This is optimal based on where we are today, based on the technologies available today. Now, as Istio matures, as Red Hat's offerings mature, we intend to move in lockstep with them and learn as much as we can as we go. That said, let's take a closer look at this service mesh architecture and see what we can see. Right? So as I said before, the service mesh is essentially a uniform architecture that is made up of a network of proxies. The lighter blue boxes are your sidecars or proxies, and they sit alongside the microservices. They all communicate with each other directly, but also asynchronously with a control plane. And this is facilitated by the CAS, which is Kubernetes, or everybody's favorite commercial variant, OpenShift from Red Hat. It speaks to a control plane. That control plane is essentially a policy point that's distributing the policy enforcement, distributing the policy governance out, the changes out, but all of the actual policy enforcement is done in the individual proxies. So you don't have the traffic traveling up and down, north, south, between the microservices and the control plane. The traffic is flowing only east-west, point to point between the microservices. The control plane is essentially distributing policies down and receiving events up so that you can have your universal telemetry. And that's the real strength of this. The amazing thing about service mesh is you can get a level of telemetry and visibility on your environment that was unheard of before. If you look in those monolithic days, there was a lot of vendors trying to sell you agent technologies where they'd say, oh, put this tiny Java application on every server, right? HP had something like that. Doesn't scale, nightmare to manage, causes all sorts of weird problems that you didn't really know were there. This approach, like a lot of things that are happening in the microservices world, is really the right answer to solving the same problem. You get fully distributed telemetry, you don't have to embed anything in your code base, and you're still ready to scale, ready to move, immutable containers, ready for public cloud. Now, if you're paying attention, you'll notice there's still an API gateway. Notice what it's labeled, perimeter API gateway. You still need some kind of demarcation point between an untrusted network and a trusted network. But that perimeter gateway is intended to be very light and very dumb. Vendors that play in this space that I think are appropriate would be things like Nginx, right? Or to a lesser extent, F5. Essentially, they're SSL termination points and ingress-egress points to get into your mesh. You still need them. They create that important demarcation, which creates security, the right security profiles on either side of the transaction. But they don't do anything logical. And they certainly don't do any kind of routing or thinking or inspection of payloads. All that stuff happens inside your mesh. When you organize your services, you do so into domains. These aren't physical structures. The design practice that you're likely to adopt is domain-driven design. And the idea is that these are logical constructs that are very malleable, very easy to change. They're driven fundamentally by conversations between your stakeholders and your developers. The idea is that they come up with a common model that they both share, which ultimately results in the design of APIs based on bounded contexts. Then you take those APIs and you turn them into microservices. In many ways, those domain boundaries replace what we historically used to call applications. So if you take a monolith and you break it down into 100 microservices, well, any notion of an application in the traditional sense sort of goes away. But you still need to be able to point to something and say, this is a set of capabilities that are organized into something of a group so that you can talk to business. That's where domains come in and fill that gap. When you have this in place, you now have resiliency, elastic scalability, cloud portability provided by the CAS. As you probably all know, all public cloud providers now offer some sort of hosted CAS environment. So you get that ability to move to a public cloud provider very easily. And the control plane gives you consistent routing, security, logging, and monitoring. So this service mesh architecture offers you that precise control and scalability while still supporting high-speed releases and fundamentally innovation. Is this a dream? Has anybody actually done this? Right? I wouldn't be standing here if I couldn't back it up with a real story. We at CIBC have actually built a service mesh. We call it our API foundation. It's based on an open source core, a framework called Light, which is architecturally similar to something like Spring Boot, but miles faster without the 12 years worth of servlet baggage that comes with Spring Boot. We brought a team in-house along with the owner of the open source project, put them in a room and said, bring this up to the level where it's enterprise grade. And that's what they did. We then pulled them out of that room and made it part of our daily operations. So we took that incubator team, put them in our shared services organization, and made it part of our daily routine, that this is how we build APIs. We build them on this API foundation, which is our microservices framework, right? We weren't content to believe the developers that what they had put together was amazing. Never do that. Don't believe your developers. They'll always say everything they write is amazing. We took it and we gave it to as many reviewers as we can think of, all of the vendors we deal with, consultancies we deal with, and they all came back with a sort of unanimous opinion. Why on earth are you doing this? Because you're not a tech company. Your documentation's kind of terrible. Make it better. And this is pretty great. They beat it up. They put it in their labs, Red Hat included. We did a case study where we integrated Red Hat's 3-scale with our Light platform, with our API foundation, and proved that the two could work together very nicely and maintain all of the truly distributed microservice principles I talked about earlier. Then we took the kit and gave it to Nordic APIs out of Europe, who doesn't know who we are, had no incentive to sort of sell us any consulting practice work or anything. And they thought it was pretty great. They ended up publishing a white paper on their website about how it was a very thoughtful framework, used open source very intelligently. Why? Right? That's the question I get asked all the time. Why on earth would you do this in-house? Just buy Spring Boot. Just buy Strong Loop. Buy 3-scale. Well, the answer is threefold. One, it's a hedge against a highly volatile market. I talked about that volatility earlier, how it's not getting better. We need to buy ourselves some time. Let the dust settle. So it's a hedge against that volatility. The second reason is to steer the technology to our needs. I'll give you an example. We were working with our customer store folks and we needed support for GraphQL because we wanted to try some stuff out. No commercial vendor supports GraphQL in their package today. We went to our dev team and say, build us support for GraphQL, and in a couple of weeks we supported GraphQL in our platform. So that's the amazing power you have when you build something in-house. And then the third, probably the most important, is to develop critical internal skills. By developing this platform in-house, we're going to learn about things like APIs, microservices, Docker, packaging, rapid deployment, automated testing, CI/CD. Those things aren't going away. Even if in 2 or 3 years we end up pivoting to a commercial platform because the dust does settle, all of those skills are going to be enormously valuable, no matter what technology we end up adopting. Those are here to stay. So that is probably the most important reason why we chose to develop in-house. Our award-winning API foundation is the first service mesh in the world that we know of that's built specifically ground up for banking, right? So we put extra rigor into the security side. We are working on exposing actual bank functions through this mesh, and we intend to keep driving on it, as well as reaching out to some partners and seeing if they want to use it too. One of the cool things about basing yourself on an open source core is we're all about sharing. If other banks come to us and say, show us the API foundation, we want to use the API foundation, we say, absolutely, let's do it. Here's the GitHub repo where you can go and get the open source core. Here's our code base, here's our documentation. Go on YouTube and watch Eyal talk about the API foundation. We'd love to work with you. So very different than the way we've dealt with platforms historically. We want to share, we want other banks to use it, and it isn't for unselfish, altruistic reasons. We are firm believers in open source. We'd love for you to clean up our bugs for us, and we'd love to get developers' eyes on this out in the wild to attract the right talent to our shop. So how are we doing on this journey? Well, we're seeing some very real results. Even though it's still early days, we only have a few microservices running in production. We've already identified potential savings of 50 to 70% per integration. That largely comes from SDLC automation. So when you start to package things into these small batch sizes based on APIs, where you take a contract-first approach, suddenly a lot of the stuff downstream becomes easier. You can automate the testing. You can automate the integration effort because you've created a marketplace where developers can go and self-serve their way towards integration. And you can automate the rollout of the necessary infrastructure. Usually you already have it in place because you have a CAS, and adding capacity to the CAS is pretty trivial. So those savings are quite real, and they don't just come from cost, they come from time as well, significantly shorter release cycles. In terms of milestones, the API Foundation core is being used across delivery teams. It is now a mandate. So delivery teams across our organization have to develop new APIs using our microservices platform. We have a governance council in place, and APIs are mandated there. Whenever projects come to the council, they have to explain why they are or are not using the APIF, and if they're not using the APIF, they have to be able to justify it. We have a managed container environment that's fully operational in both test and prod based on OpenShift on-prem. We're working on getting to a hybrid world where we have public environments that integrate seamlessly with our private on-prem CAS. Ongoing developer training for APIs and microservices, this is a big one. Very important to make sure you have a training program in place so that folks understand how to do this. Earlier it was said that it's pretty straightforward to get the technology where you want to go, but if you don't have a discipline around when do you code a microservice, how big or small is that microservice, why am I doing this at all, then you end up potentially causing more issues and creating more complexity than you had when you were still running monoliths. So that training course is absolutely critical. We've now gotten to the point that we've trained 200 developers internally on our foundation, and we encourage them to keep coming back because the technology is moving. We are adding new features, so we want to maintain that connection to the developer community. And finally, we're piloting, actually that's not accurate. As of about a week ago, we are now GA. So we have a GA release of our internal API marketplace available today at marketplace.cibc.com if you were on our internal network. And it is exactly what it sounds like, a developer portal. The developers can go and see which APIs were published, be able to try them out, and register to consume them. You can also publish your APIs through the marketplace where it will use our framework to auto-generate a microservice for you. Not quite at the point where we're auto-deploying to the CAS yet, but that's where we want to go. It's worth noting the marketplace was developed largely in-house as well. The last thing we wanted to do was throw 200 features at developers which they didn't understand and will never use. We started with an MVP approach to marketplace and have reached out to the developer community to understand what they'd like to see from future versions going forward. Big focus on community building, big focus on feedback mechanisms. Did the API Foundation really win awards? Is that just something you say, award-winning? The answer is yes, we did actually win a couple of awards. We were recognized by Nordic APIs as being a leader in microservices in one of their conferences. At the end of last year, we received an award from InfoWorld and Forrester for innovation within enterprise architecture with a specific nod to the API Foundation. And watch this space. There's some stuff that I can't talk about, but we are expecting some more accolades in 2019. So we're very excited about where we're going, but we recognize this is a journey. This is not something we're done. This is still going to keep rolling, and we recognize there's a long way to go. So where are we going? Well, we're going, like all of you, to the bank of the future. Right? Now, what does the bank of the future look like? And I'm going to reiterate the point I made earlier in the presentation. Open banking only regulates the top of the stack. Open banking, in terms of the regulatory approach, only refers to your API strategy and to a certain extent your platform insofar as it means your collection of APIs. But to do this properly, you need all four of these pillars. You need APIs, you need Agile, you need DevOps, and you need cloud. And they all work in lockstep. If any one of these starts to drag, they end up pulling back the other three. Because if you have great APIs and Agile processes for delivering those APIs and DevOps for automating the deployment, but you don't have cloud, well, you're just going to pay through the nose for your on-prem CAS and constantly be chasing the tail of the public providers. If you have agility and you have DevOps and you're even running your DevOps pipeline right into the public cloud, but you don't have an API discipline, you're just going to create a mess of microservices everywhere. if you end up with everything except for your DevOps? Well, you're just going to hit constraints when you try and deliver, right? So you have great APIs. You even have agile processes for defining those APIs. But you don't have a DevOps pipeline? Well, you're just going to create a lot of microservices on laptops and not be able to deploy them anywhere, right? And which one did I leave out? Agility, right? Maybe the most important because it's the constraint at the front. So even if you have JSON, REST APIs, and you have a DevOps pipeline for turning them into microservices and deploying them right into the public cloud, but you don't have agility, how are you going to develop requirements? How are you going to engage with your business stakeholders? So all these things run in lockstep. And if you aren't trying to address them together, you're constantly going to find yourself being dragged back. Crucially, it's not just technology, right? Those 4 pillars are still technology-oriented pillars. You also have structural and cultural challenges that you have to address as well. Our organizations typically are not structured in these nice vertical teams based around function. They're typically not structured around openness and sharing of data and trying to find new opportunities for revenue that are perhaps outside our hero product mentality. So dealing with those cultural and structural challenges is very real as well, and something that has to be considered as you move towards this bank of the future. So the pillars, right, they give you that delivery speed that we talked about, but it's only that cultural change that embraces, only that culture that embraces change, that embraces constant innovation, constant flux, is going to get you to that point where you can truly support open banking properly. From a technology standpoint, we see this happening all across the industry, right? You're seeing the metaphors for IT systems change. For the last few decades, metaphors for IT systems have been centered on fixed things. When we said architecture, we sort of kind of meant architecture like in the real world. We're building buildings or bridges or cities or plumbing, something that is fixed. Now the thing is about fixed things is you have to get the design right up front, because if you didn't get the math right on your bridge, the bridge will collapse. You don't want that. Software, not so much. Right? In an age of scarcity, where you were building for systems where every CPU costs you money, well, you kind of are stuck with that because of cost-benefit reasons. But in a world of abundance, where you have essentially unlimited computing resources, and every function of your application can be packaged as a tiny microservice and scaled and deployed independently, well, suddenly the way you approach design changes radically. You move from this world of very fixed things to a world that looks much more like biological systems that are built to change, that are ever-changing, that are constantly evolving. And the metaphors shift from bridges and buildings and cars to things like cells, molecules, and organisms. Right? This is best captured, I think, by a quote from the king of microservices, Martin Fowler. It says, "There is no design at the beginning. You begin by coding a small amount of functionality, adding more functionality, and then letting the design shift and shape." Taking this approach to design, where you're creating systems that are fundamentally built for change, is the only way that you're going to accommodate this constantly changing environment of open banking, where customer expectations are shifting left and right. Your competitors are shifting left and right. The question earlier was, what is the end game here? The answer, no one knows. So you better build your systems for change. Thank you very much for your time. It's been a pleasure talking to you today.